All right, so today we're going to be talking about quadratic inequalities. So when I talk about quadratic inequalities, first of all, let's review a couple things about quadratics. First of all, quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? That's the first thing we need to talk about. Then let's talk about some things with inequalities. And, going back. When I solve this actually gives my x-intercepts, right? That's what we're solving for with the quadratic formula, is where the line is crossing the x-axis. So when we talk about inequalities, remember we have our four symbols. If it's a regular, greater than or less than, you have an open circle. If it's an equal to, you have the closed circle. Okay? Going to have to use both of those today. The other thing we need to talk about is with quadratics, we get a parabola, right? So our solved numbers are going to be where it's crossing the x-axis. So your parabola would look something like this with basically this is your x-intercepts, right? So with quadratics, we always have to have it equal to 0, right? Now with inequalities, that means it's going to be either greater than or less than 0. So if we think about this as the x-axis, what values are greater than 0 as far as the y goes? It would be everything above it, right? These are all the values that are greater than 0. These are all the values that are less than 0. So that'll help us kind of visualize what we need to do when we are graphing an inequality. So let's look at a quadratic here. Let's start with the normal one. So let's look at number 3 here. Let me zoom in a little bit so you can see better what I'm doing. Okay. So that gives us a pretty good image there. So here's my quadratic. Again, anytime I'm using the quadratic formula, I always start by identifying my a, which is 1, my b, which is negative 4, and my c, which is negative 12. Okay, that gives me my stuff I need to plug into my quadratic formula. So again, quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So negative b would be 4, because negative 4 would be 4. Plus or minus the square root of negative 4 squared would be positive 16, minus 4 times a, which is 1, times negative 12. So negative 4 times negative 12 would be positive 48, right? 4 times 12, yeah, 48. So plus 48. Well, 16, and that's all being divided by 2, right? 16 plus 48 would be 64. Square root of 64 is 8. So I'm going to have 4 plus 8 all over 2 and 4 minus 8 all over 2. Well, 4 plus 8 is 12 divided by 2 would be 6. So I'm going to have x equals 6. 4 minus 8 is negative 4 divided by 2 would be negative 2. So x equals negative 2. So this all started as an inequality, right? Now notice I didn't write inequality here. That's because I'm basically just looking for my x-intercepts. So this is where it would cross the x-axis. It's going to cross at negative 2 and at positive 6. And it's a regular inequality symbol, so these are going to be open circles. Okay? Now, next thing, this is why it helps to visualize this parabola. If these are my x-intercepts, that means that my parabola is going to cross the x-axis at these points, right? Next question, is it opening down or opening up? We can always tell if it's opening down or up by the a. If a is positive, it's going to open up. If it's negative, it's opening down. So if it's opening up, that means it has to have a vertex below these points. And I'm drawing this in pencil because this isn't technically part of my graph of the inequality. Okay? So it is technically down below. So if I'm looking for where this parabola would be above 0, It's when it is above my number line here, right? So what values are above the number line? Well, it looks like it's everything that's less than negative 2 and everything that's greater than 6. Everything between them would be underneath the x-axis. And now I'm going to erase this because I no longer need it. And that would be my number line. Everything that's less than negative 2 is going to be above 0. Everything that's greater than 6 is going to be above 0. Everything in between them was less than 0. Okay? Then I have to do my interval notation. There's two different intervals here, right? Remember with interval notation, we have parentheses and we have brackets. We use brackets when we have a closed circle. Infinities and anything with an open circle would always have a parenthesis. So this least number would be negative infinity. Greatest would be negative 2, and it's an open circle and an infinity, so they're both going to have parentheses. Then I put my union symbol there, and then I'd have parentheses 6 comma infinity. Okay? And that's all you're doing there. Now, there are some special cases we might run into. Remember, not every quadratic has two solutions. Some of them only have one. Some of them have no real solutions. They have imaginary solutions. On the imaginary ones, you're not going to be able to graph or do anything, so you can just write no real solution. But on one solution stuff, so let's look at number 6, for example. So this one, again, let's use our quadratic formula. So a is equal to 1, b is equal to 14, c is equal to 49. Okay. Plus negative b, so negative 14, plus or minus the square root of 14 squared is 196. Minus 4 times 1 times 49. So 4 times 49 is negative 196. All over 2. Well, 196 minus 196 is 0, right? Square root of 0 is 0, so all of this stuff goes away. And I'm just going to be left with everything outside. So negative 14 over 2, which is equal to negative 7. Okay, so there's only one solution here. What does that mean? Well, that basically means the vertex of the parabola is on the x-axis, right? That is the only way that a quadratic only has one x-intercept is if it's the vertex, because otherwise you would have two, right? Any point on that line after 2, there would be two different lines. Now, since there's only one here, that is going to be my vertex. Question is, does it open up or does it open down? Well, A is positive, so that means that if that's the vertex, it would be opening up. It would look something like that, right? Again, that's not actually part of my graph here, so I just did that in pencil. So this is equal to 0, so I'm going to put a closed circle, and it's everything greater than or equal to 0. Well, what parts are greater than or equal to 0? Well, everything to the left is greater than 0. Everything to the right is greater than 0. Add negative 7, it is at 0. So technically, there is nothing in this equation that is not greater than or equal to 0. So technically our graph is doing that, and it's technically going from negative infinity to infinity. There is no missing piece here. It covers all real numbers. Okay? So a little bit of a trickier one. Let's look at the next one. So this one also is a little tricky. So 9 would be A, and then B would be 36. C would be 36. When I plug this in, it would be negative 36 plus or minus square root of 9 squared, or not 9 squared, 36 squared, which is 1,296. And then minus 4 times 1 times 36 would also be 1,296. So minus 1,296. All over 2 times 9, which would be 18. So that goes to 0. So I'm left with negative 36 over 18, which is equal to negative 2. So again, only one solution. Negative 2, it's equal to 0, so it would be a closed circle. Again, A is positive, so it's going to be opening up like this. Well, the thing that's different about this versus the last one is it is wanting everything that is less than or equal to 0. Well, there's nothing less than 0 here, right? Everything is above the line. We do have one point that is equal to 0, negative 2, but other than that, everything is above 0. Well, that negative 2 is technically part of the interval, right? It's the only thing that falls in the interval, so my interval notation would just be negative 2, because at negative 2, it's equal to 0. Other than that, there's nothing that fits. And that's what you're doing with quadratic inequalities. So today we are going to talk about rational inequalities. So first of all, just a couple quick steps. First thing you want to do is you want to move all the junk to one side. Okay? So you want all that junk to one side. You don't want anything on the same side. So everything that, if you have stuff on both sides, you want all of it on one side. So you want it equal or greater than or equal to or less than or equal to 0. All that stuff. Then, once you have everything to one side and simplified, you set it all the x's equal to 0. Just kind of like you did with the intercept form with the graphing quadratics. You want to set it all equal to 0 so you can solve for your x-intercepts. Okay? Then, you put all your solutions on a number line, and then you're going to test your solutions. Okay? So let's look at an example. So if we look at number 1 here. Now let me zoom in here a little bit. This is a little bit smaller font. So, okay. I'm still zooming in. Zoom, zoom, zoom. Okay. So I have all this junk on this side. I'm going to try to move it over to my other side here. So if I want to move a fraction, I just subtract the whole thing. Right? Minus 6 over x plus 2. Minus 6 over x plus 2. So cancels out here. You're going to be left with x over x plus 2 minus 6 over x plus 2 greater than or equal to 0. Now, in order to combine a fraction, it has to be the same denominator. In this case, they are the same denominator, so I can just copy them over. But what if they weren't? What if I had like 5 over 8 and 2 over 3? And I wanted to get them to the same, or I wanted to be able to combine them. Well, in order to do that, I would have to multiply each one by the other denominator, right? I have to multiply this by 3 over 3 and this by 8 over 8, okay, in order to do that. So you are going to have situations today where you have to multiply like 1 over x plus 2 by something like x minus 3. Okay? You are going to have to do that today. And it's honestly not that bad because you want them left in this parenthesis form anyway because you want to set each parenthesis equal to 0. Okay? But let's come back to number 1. These already have the same denominator. So I'm going to combine them. When I combine them, I don't do anything with the denominators, right? X plus 2 stays in the bottom. All I'm combining is the stuff on top. So it'll be x minus 6 over x plus 2. You don't ever, combine the denominators. They're always the same, right? If it's dividing by that, you leave it dividing by that when you combine them. You just combine the top numbers. Is greater than or equal to 0. Well, now I have it separated. So now I take my 2 x's, and again, this is just like when it was intercept form. These are going to give me my x-intercepts. So you set them equal to 0. So x minus 6 is equal to 0. X plus 2 is equal to 0. And then you would solve those. And you would get x is equal to 6 and x is equal to negative 2. Now we're going to plug those on a number line. So I'd get negative 2 and 6. And these are greater than or equal to. So I'm going to use a closed circle. But with rational inequalities, on the denominator, you cannot have 0 in your denominator, right? So if I plug in negative 2, Negative 2 plus 2 is 0. I would get an error. So with the denominator one, it is always going to be an open circle. And you can't even see what I'm doing because I zoomed in too much. Sorry. Let me zoom out a little bit. So you're always going to use an open circle with the one that is from your denominator. So the negative 2 was from the denominator, so that always has to have an open circle. And then, to do the rest of this, we're going to have to test. So we're going to have to test. These are crazy looking functions. They kind of jump all over the place. So we're going to have to test by plugging numbers in before negative 2, between negative 2 and 6, and after 6. So to test those, I'm going to plug in a number that's before negative 2, so let's plug in negative 3. So parentheses negative 3 minus 6. Oh, actually I have to minus a 6. Divided by, and notice how I'm putting them all in parentheses. That's the way it's dividing the entire thing. Negative 3 plus 2. I'm sorry, I didn't put those in parentheses. Negative 3 plus 2. And then I get positive 9. Well, I'm looking to see what is greater than or equal to 0. So 9 is greater than or equal to 0, so that means everything less than negative 2 works. Now let's try something between negative 2 and 6. So easiest way to do that is just plug in 0. So I'm going to plug in 0. So parentheses 0 minus 6 divided by parentheses 0 plus 2. Which is negative 3. Negative 3 is not greater than or equal to 0. So this range right here is not part of my inequality. So I'm going to test the number after 6 now. So let's try 7. 7 minus 6. Oops, need to use parentheses. Parentheses 7 minus 6 divided by 7 plus 2. Which is 0.1 repeating, but that is greater than 0. So yes, everything after 6 also works. So my interval notation would be negative infinity to negative 2 with parentheses, union, then bracket 6 comma infinity parenthesis. Okay? So again, the trick here is to find your intercepts, put them on a number line, and then just test what actually works. If it is actually greater than or less than what it's saying, then it works. If it's not, then that is not included in your interval. Okay? So, for example, here, these x's on number 3 here are already set up. They're already isolated. So I'd set this up as x plus 3 equals 0, x minus 2 equals 0, and then x minus 1 equals 0. There's technically 2 of those, but you're going to get the same answer either way. So x minus 1 equals 0. And you're going to get x is equal to negative 3, x is equal to negative 2, x is equal to 1. Sorry, that's a positive 2. And then that gives me 3 things I need to put on my number line. Okay, this is a regular inequality, so they're all going to be open circles no matter what. So I have negative 3, 1, and 2. And all I'm going to do here is I'm going to test between every range. So I've got to plug in numbers before negative 3, between negative 3 and 1, between 1 and 2, and from 2 after. So I'll let you do that later. And if it is actually greater than 0, you draw your arrow, it's included. If it's not, then you don't draw anything there. Okay? If it's already in quadratic form, then you just use the quadratic equation. You set up the A, B, C, and you would get your x-intercepts, right? So you would do like 1, negative 6 for your A, B, C, plug that in the quadratic formula, and that's going to give you your x-intercepts. On the top, there's also 2 on the bottom here, so you got to solve for both of those. So you could technically have 4 points there, but one of them is the same on both, so it's only going to be 3. But that is basically what you're doing for rational inequalities.